Morning all of you. Welcome back to our course Artificial Intelligence. Our today's topic of video is AI problem characteristics. So why there is a need to study the characteristics of various problem? So it is very important while deciding a technique used to solve a particular problem. We should know what kind of problem it is. If you carefully analyze the problem, then easily you can decide a technique that you can use to solve a particular problem. That's why these 7 characteristics are given in order to identify what type of problem it is. So let's discuss what are the different characteristics of AI problem. So these are the various characteristics of AI problems are there. Is the problem decomposable? Can solution steps be ignored or undone? Is the universe predictable? Is a good solution absolute or relative? Is the solution a state or path? What is the role of knowledge? And does the task require human interaction? These are the 7 characteristics of different problems in AI, which help us to decide what kind of technique that we should use in order to solve a particular problem. So now we discuss all these characteristics one by one. So very first characteristic is the problem decomposable? Decomposable means what? Divisible. Can we able to divide a problem into number of sub problem? Is it possible? It is not possible in every problem. There are certain problems are there where you can divide one large problem into number of sub problems, and where these sub problems can be solved parallelly, individually, and then their solution combines together to get a final solution. Maybe you heard about this strategy, divide and conquer strategy. In the subject of design analysis and algorithm, you might have heard about this divide and conquer strategy. So as per divide and conquer strategy, we need to divide one task into number of subtasks. Then we have to carry it out subtask individually. Then whatever the solution generated for this individual task has to be combined so that you will get the final solution. So that is the thing. Is the problem decomposable? Whether a particular problem can be decomposed into number of sub problem. Is it possible? That you need to identify. So decomposable problem can be solved very easily, as shown in this particular diagram. The equation here, you can see this is the equation. Here it is decomposable. Suppose somebody asks me whether means I need to solve this particular problem. So by looking at this, we can say that yes, it is decomposable. Why? Because here you can see you can apply this derivative you can apply this derivative or integration individually on this term. X square is one of the term, 3x is another term, sine square x into cos square x, this is another term. This is again divided into 2 parts like this. That means we can say that this is a one problem which is divided into 3 subparts, 1 2 3. So what we will do, we'll solve it individually. Whatever the solution generated, that solution we can combine so that we'll get a final output, or you can say yes, final output. So this is what is the problem decomposable. This is another diagram which illustrates the concept of decomposition. Here you can see that division can be done here on b comma c, that is one part, on a comma b, this is another part. A is a separate part, okay, then these are the separate parts. So in this way, this is these are 2 diagrammatic representation of decomposition. So main thing is that first characteristic is the problem decomposable? Whether can we decompose or divide a problem into subtasks. Then the next characteristic is, can solution steps be ignored or undone? Okay, so in this case 3 things are there: ignorable problem, recoverable problem, or irrecoverable problem. Ignorable problem is what? See, I will give simple example to illustrate this so that you will understand what is a ignorable problem. Ignorable problem, so which example we have taken? Theorem proving. I need to prove a particular theorem. You might remember that in 10th you have subject geometry, where you need to prove the theorem, where you need to prove the things LHS equals to RHS. Particular theorem is there that you need to prove. So in that case, is it every time if we observe the particular student will bring LHS equals to RHS, but if we carefully observe the intermediate steps, then we may find that some problem may be there, some issue will be there in the intermediate step, but still you can find at the final solution LHS equals to RHS. So theorem proving is a ignorable problem. Maybe the case that particular step can be ignored. Okay, suppose in order to prove the particular theorem you require 10 steps, but it might be the case that particular student ignored step number 7, but still he can able to achieve that LHS equals to RHS. Okay, so this is the case. Theorem proving is a ignorable problem, is we can ignore some steps. Okay, ethically or technically we need to means we don't have to forget any of the steps, but still we are getting the solution that LHS equals to RHS, still we are missing any of the steps. So this is what a ignorable problem. Then next one is a recoverable problem. In recoverable problem, just like a 8 puzzle problem, here I have shown you diagrammatic representation of 8 puzzle problem. In case of a 8 puzzle problem, this is a blank tile that I have to move either in the left direction, right direction, left, right, top, bottom. Like this I need to move the tile. Okay, so in this case what we are saying, recoverable problem is solution step can be undone. Suppose I have moved this tile this side, again can I come back to my original position? Is it possible? Yes, it is possible. So 8 puzzle problem is a recoverable problem is that kind of problem where a particular step which you have taken can be undo, means you can undo the steps. Here I move this tile in upward direction, again I can come back to my original position. That's why I'm saying that this 8 puzzle problem or 8 puzzle game is a recoverable problem. Then the third category is irrecoverable problem. Its example is chess. So in case of chess, you know that various elements are there. King is there, queen is there, okay, pawn is there. Okay, suppose you have taken the move for king, or suppose you have taken the move for queen, we can say that it is a recoverable, because we can bring that queen to that position if there is that place is vacant. But this is not a case in case of pawn. If you move the pawn in the one step ahead, you cannot take it back. Okay, so it is irrecoverable problem. Once you play a move, particular move, we cannot reverse it, we cannot undo it. That is what a irrecoverable problem. In the game of chess, while moving the queen, we can say it is recoverable, because if the space is vacant, that block is vacant, you can bring back that queen to the previous position. But this is not a case in case of pawn. If you are moving the pawn in one place ahead, you cannot bring back to the previous position. So in case of chess, we are saying that it is a irrecoverable problem. Okay, so I hope you understand. Can solution step be ignored or undone? So this 3 kind of problem can be there. You need to identify whether it's a ignorable problem, recoverable problem, or irrecoverable problem. Now the next characteristic is the universe predictable? Is the universe predictable means what? There are certain problem where solution is somehow predictable, and there are certain problem where solution is not predictable. In terms of machine learning, you can say that in case of classification problem or in case of supervised learning, yes, in case of supervised learning, you can predict the output, what output you will get. Suppose I ask small children to classify the image between cat and dog. So here your outcome is predictable. You can either get cat or you can get a dog. Okay, that means here output is predictable. But in case of a clustering problem, in case of unsupervised learning, you don't know exactly what output you will get. Just simple example, just consider that you have grocery shop at your home, and suddenly inventory comes, and now you have to sort out into various category. In advance, do I know how many categories I need to form, or how many categories can be formed? No, I don't know. Based on the inventory, I decide to divide the things, and at the later stage I come to know that that many categories are formed. Based on the similarity, you will group. Means if that inventory has to be sorted out by different person, they have their own criteria to divide this grocery into different sections. So they don't know exactly. Maybe suppose that inventory is given to me, I will divide all this inventory into 5 groups. Suppose it is given to you, you may divide it into 6 groups. That means in this case your output is not predictable. So in case of clustering, you can say that your output is not predictable. Every time may be the case that your output may change, but this is not the case in case of a supervised learning, especially in case of a classification problem. In case of classification problem, in advance you should know either you will get a dog or you may get a cat. Similarly, there is a spam classification problem. Spam, so in that case you can say that either mail is spam or not spam. That means output is known in advance to the user. So this is how the characteristics is the universe predictable. So here we have taken another example, that is a 8 puzzle problem. So in case of 8 puzzle problem, we can say that it is outcome is certain outcome will be there, because if you are playing 8 puzzle game, once you move the tile from one position to another, you know what happened. Okay, what happened. For certain outcome problem, planning can be used to generate a sequence of operator that is guaranteed to lead to a solution. So in short, what is the meaning of this? The meaning is very simple. In this case, your outcome is predictable. Okay, and another example is that playing the game of bridge. It is a cards game. Okay, playing cards game. So in case of bridge game, you can say that your outcome is uncertain, because whatever the move that is to be taken by another player, you don't know what is a move by another player. So we can say that in this case outcome is uncertain. Okay, so this is what next characteristics, that is the universe predictable. The next characteristics is that is a good solution absolute or relative. Whether the solution that can be generated for particular problem is absolute solution or relative solution. So in order to demonstrate this, I have taken 2 examples, one as a absolute solution and another is a relative solution. So in order to represent the absolute solution, I have taken this example. Actually it's an example of knowledge representation. In later videos we are going to understand what is knowledge representation, how to solve a numerical based on knowledge representation. So it is one of the problem based on knowledge representation based on the predicate logic. So these are the facts. Okay, these are the set of facts given to you, that Marcus was a man, Marcus was a Pompeian, Marcus was born in the 40 AD, all men are mortal, all Pompeian died when volcano erupted in 79 AD. No mortal lives longer than 150 years, and it is now 1991 AD. These are the facts given to you, and question is asked that is the Marcus dead? You need to decide. So in this case we are saying that this is an example of absolute solution or absolute problem. Okay, why is it so? Because based on this you may derive the conclusion like this: Marcus was a man, all men are mortal. Okay, Marcus is mortal. Marcus was born in the year of 14 AD. It is now 1991 AD. So Marcus' age is 1951 years, and no mortal can live longer than 150 years. So based on this, I can conclude that Marcus is dead. So I can say that this solution is absolute solution. Means comparative analysis cannot be there. Means more than one solution we cannot derive in this particular problem. But as compared to this one, there is another problem called as a traveling salesman problem. So in the traveling salesman problem, it is very simple, that you need to find such a optimal way or optimal path which is having cheaper cost. Okay, cheapest cost to reach from. Means in traveling salesman problem, we want that salesman has to visit to each and every city, but their sequence is not fixed. Okay, their sequence has to be decided by you, but the thing is that total cost of this complete path should be minimum, the total cost should be minimized. So this is what a traveling salesman problem. So in case of a traveling salesman problem, here you find that there are two routes we have found. One route having a cost of 8850 and another path whose cost is 7750. So in this case we can say that it is a relative solution. Relative solution means what? In the particular problem more than one solution can be generated, and then you can compare the solution which is a better solution, which is a cheaper solution, which is a minimized solution. So that kind of problem we can say that there is a relative problem, absolute problem or relative problem. There are certain problems where solution generated, only one solution can be generated, there is no possibility of just comparing it. But there are certain problem where more than one solution can be generated and then you can compare, just like here in a traveling salesman problem. We have to try all the paths to find the shortest route. Okay, so this is a characteristics, is a good solution absolute or relative. Now the next characteristic is the solution state or path. State means what? Directly the location. Path means you have to start it from initial position and you have to reach up to the destination. Just I have taken this a simple example, finding the route to Eternity Mall in Birdi from Shankar Nagar. So we can say it is a path, means there exists a path from initial state to the final state. That means you need to move. We have solved the problem of water jug problem. There we have initial state, also we have final state from where we are moving it. So is the solution state or path? In case of path, you are moving from initial state to final state, but in case of a state, you have exact location. Exact location of Eternity Mall in Birdi considered as a state, means exact particular location. So this is what a state. So this is a characteristics, is the solution state or path. Next characteristics is that what is the role of a knowledge. Now there are certain problems which required knowledge to solve it, and there are certain problems you can solve without having knowledge of it. Just we'll take a simple example over here. In order to read a newspaper, do you require a particular knowledge? Obviously language is important. If you are saying that you know the language of Hindi and you are reading the Telugu newspaper, can you able to read it? No, obviously language is required, but still we can say that in reading a newspaper, specific or specialized knowledge is not required. But while playing a particular game, let's say playing the game of chess, you required the knowledge. That means rules should be known to you. Unless and until you are not aware about the rules that we follow in order to play the game of chess, you cannot play. So we can say that while playing the game of chess or any kind of particular game, knowledge is required. But in case of reading newspaper, specific knowledge is not required. Again, in order to perform market analysis, economic analysis, specific knowledge is required. We talk about various task domains of AI, so there we understand specialized tasks, okay, mundane tasks. So in case of specialized tasks, you require a specialized knowledge. Similar thing is this: what is the role of knowledge in order to solve a particular problem? So we found that particular problems are there which can be solved very easily. Prior knowledge is not required. Now the next characteristic is, does the task require human interaction or not? There are certain problems where you require human interaction. There are certain problems where we do not have any kind of human intervention, means that problem can be solved without interaction. So we have taken these two examples. Theorem proving, in order to prove the theorem, do we require interaction? No, obviously. Suppose one theorem is given to you and you have been asked to prove it, that means you have to bring anyhow LHS equals to RHS. So in that case there is no such kind of interaction will be there. But another example is of medical diagnosis. Okay, in case of a medical diagnosis, obviously human interaction is required. You need to convey what are the symptoms that you are suffering from, what are the problems that you are facing. According to that you are telling this problem to doctor, then doctor will according to their diagnose the disease as well as give prescription of medicine. So we can say that this problem you required human interaction. So I want to tell you that there are certain problems where you require interaction, and there are certain problems where we do not require interaction, but that can be done very easily without any interaction. So these are the 7 characteristics are there, and based on this we have summarized the different problem, because in case of artificial intelligence we need to solve different problems are there. We have to generate state space representation. So we have chess problem, water jug, 8 puzzle, traveling salesman, tower of Hanoi, bridge problem, and on the this row 7 characteristics are there. So they have been mentioned in case of chess whether it is decomposable, no. Water jug is decomposable, no. Suppose we talk about water jug problem that we have discussed, whether it is decomposable, no. Whether in this case solution step can be ignored, and yes. Whether universe is predictable, yes, because we have initial state and final state. So finally we know what is a output that we want. So universe is predictable. Whether the solution is absolute or relative, so we can say that any path, it is a path because we are moving from initial state to final state. Then knowledge is required, yes, obviously. Rules required, and user interaction is required, no. There is no interaction is required in order to solve this problem. So this is how different problems are considered and their characteristics are summarized. So I hope you understand what are the different characteristics of a AI problem. So these are important, these characteristics known to you, because you need to analyze the problem. First of all, you need to understand what kind of characteristics it satisfies, and then you can apply different techniques to solve it. Thank you.